Picking up where we left off, we're looking for the equation of the line with a slope of -5 that goes through the point -1,7 using the point slope form. I begin by writing y minus the given y value, or the y value of the given point, equals the slope times x minus the given x value of the point. So x minus a -1 is what we have. And before I remove the parentheses, let me simplify the inside of the parentheses. Minus -1 changes to +1. So now it's -5 times those things inside the parentheses. We get -5x minus 5. And adding 7 to both sides, we'll get the y by itself. So on the left side, we just have y. On the right side, we have -5x plus 2. So there's my answer. There's the slope-intercept form of the equation of a line with a slope of -5 that goes through the point -1,7. Let's see if it really works. If I draw this, just using this, I start at that y-intercept of 2. -5 for the slope could be thought of as -5 over 1, or 5 over -1, or just -5 over 1. Anyhow, we go down 5 boxes, and over 1 this way, so that it's going downhill. Because it's a negative slope, it's got to go downhill. Can I do that one more time? Down 5 over 1, we're right there. Or I can go up 5 and to the left 1. And if I draw that as neatly as I can, freehand, certainly it has the correct slope. Does it go through -1,7? Let's check that. There's where x is 0. There's where x is -1. And then 1, 2, 3, 4, 5, 6, 7. That's the point we were supposed to hit. That's the point. -1 for x, 7 for y. So it fulfills both requirements. That's the answer, and that was doing it algebraically. And these next two questions, or last two questions for this, oh, I'm sorry, I almost missed one. There's one more over here, isn't there? Slope is -2, goes through this point. So I'll write y minus the y value of the given point equals the slope, -2, times x minus the x value of the given point. And I think you know how this goes by now. Change this to +5. And this becomes -2x, and then minus -12, or just +12. And if we take away 5 from both sides, we'll get the y isolated. It'll then say y equals -2x, 12 minus 5 is 7. So we have a y-intercept of 7, which would be way up here. A slope of -2, means go down 2 over 1. And you're not going to have to draw these graphs every time you do this work. I'm just doing it right now to try to have this idea make sense, and also to show that these answers do what they're supposed to do. We're supposed to have a slope of -2. We took care of that. Does it go through the point 6, -5? 2, 4, 6. And then 1, 2, 3, 4, 5. There's 6, -5 right there, and the line is going through that. So we fulfilled both obligations of the question. Now we can look over here. We want the equation of a line that's perpendicular to y equals -1/2 x plus 7, and that goes through the point 925. So remember, how do we make lines perpendicular? Give them the opposite reciprocal slope. So this line has slope -1/2. The reciprocal would be 2 over 1, and the opposite reciprocal would be just a positive 2. So if we use positive 2 for the slope and use this for the plug-in point, I'm sorry, I went off the screen there, didn't I? Use positive 2 for the slope and use this for the plug-in point with the point slope form. Let's see what that looks like. Y minus the y value equals the slope times x minus the x value. So if we remove the parentheses, we get 2x minus 18, and then add 25 to both sides, and we have y equals 2x plus 7. So, is this the equation of a line that is perpendicular to the given line? Yes. How do we know that? Because the slopes are opposite reciprocals. These numbers have nothing to do with it. Okay, so the slopes are opposite reciprocals. So that means we've definitely got perpendicular lines. Does it go through the point 925? Well, the way to check that is plug in a 9 for x. 2 times 9 is 18. 18 plus 7 is 25. So we're getting the y value that we're supposed to, 25. That's how we know it's correct. And then after doing that, maybe this looks kind of easy. To make the equation parallel, make the equation of a line parallel to the given line, we use the same slope. And let's do this the other way. We'll write y equals 3x plus b. If we use the same slope, they're definitely going to be parallel. How do we make it go through this point? Plug in these numbers for x and y and solve for b. And you would get the same answer in the end as if you used the point slope format. Oh, but I'm going to use this. This is usually a little faster. So 37 goes in for y. 10 goes in for x. So now we have 37 equals 30 plus b. Take away 30 from both sides, and then it will say 7 equals b. Getting 7 again. Coincidence. So the answer is y equals 3x plus 7. How do we know whether this is correct or not? Well, what are the two things that have to be true? The lines have to be parallel. They have the same slope. That guarantees they're parallel. The other thing is it has to go through this point. How do we see if it goes through this point? If we plug in 10 for x, does the equation spit back 37 for y? It does. Plug in a 10 for x, it's going to say 3 times 10 is 30, plus 7, 37. All done. Thank you for listening, and that's the end of day 45 lecture notes. Bye-bye.